Okay, so we're going to pick up today with another example. I'd like to do the full state plan to conclude for this one. Yeah, that's why I left like the whole page for you. It says, as the Spanish-speaking population in the U.S. has grown, businesses have increased their focus on providing both English and Spanish options for customer service. One study interviewed a random sample of customers leaving a bank. Customers were asked if they spoke English or Spanish when talking to bank representatives. Each customer rated the importance of several aspects of bank service on a 10-point scale. Here are summary results for the importance of reliability, the accuracy of account records. Calculate a 95% confidence interval for the difference in the population mean reliability ratings of customers who speak English and customers who speak Spanish when talking with this bank's representatives. Assume the conditions for inference are met. Does the interval in part A provide convincing evidence of a difference in population mean reliability ratings? Justify your answer. So we're going to tackle A first. What is A asking us to do? Confidence interval, very good. And it is a confidence interval for a difference in means, population means. Very good. So I know that I am doing a interval for mu1 minus mu2. I know I need to define both of those. I also, good morning, need to decide whether this is Z interval or T interval. I hear T, very good, because the only standard deviation we're given is in the table with the sample data. So I know that this is an X bar and this is an SX. Good. So T interval for a difference in means. We're going to define our mean. So mean 1, what is mean 1? So pop mean reliability rating, yeah? That is a lot of writing here. Of, come on, pen. Of customers who speak, and are we going to make one English or Spanish? English. Usually it doesn't really matter. You can do either. It's good practice to do it in the order they mentioned it in the problem. So the first one that gets mentioned is labeled 1. It is not that English is better. It was just mentioned first. Next one is the same thing, except now it's customers who speak Spanish. So I am going to do a whole bunch of blah, 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 because we're copying, except the only thing that changes is here. We're now looking at Spanish speakers. So 2 populations, customers who are interacting with their bank representatives in English, customers who are interacting with their bank representatives in Spanish. Separate populations. Good. What other information do I need? Sample size. And they were nice enough. I'm going to come up here and label it because they didn't label it. They just said N. This is my sample size. I'm going to label English row 1, Spanish row 2. They were nice. They labeled mean and SD in words, and we just attached symbols. What else? Confidence level. Yeah, I do need a confidence level. So for my T interval, I'm going to use a confidence level CL equals 0.95. And I'm going to find my critical value now that I know my confidence level, because that has nothing to do with my sample and everything to do with how certain I want to be. So it's a T interval. I'm going to draw a picture for the T distribution. I'm going to slap 95% in the center of that curve. what does inverse T want? Left tail, very good. So how much is in my left tail? 0.025, very good. 2.5%, because 5 left for the tails, cut it in half. Perfect. And then I need degrees of freedom. So df1 and df2. So what is the degrees of freedom for sample 1? 91. Degrees of freedom for sample 2? 85. Which one are we going to use? Lower one. Very good. 85. So 0.025, 85. That information is going to give me my critical T star. I'm going to give you a second on your calculator to run that. I guess I could also run that. It's so slow. I'm getting 1.988. Perfect. Perfect. That would be sufficient for the state. I've stated what I'm doing. I've defined the population parameters. I've kind of labeled all the numbers I was given. I've found my critical value. So everything I need to carry out the rest of this process is on the paper. Mario, what comes next? You did the state step. What comes next? Conditions. Very good. The plan step. We got to check those 3 conditions. I know they said to assume. We never assume. We're going to do the whole state plan do conclude for practice. So we're going to do our checks. We have 3 of them. Everybody knows the first one is random. What is the second one? Independent, because we did sampling here. Independent. And then the last one, normal. Very good. And we check it for both samples. So, random. Are we told random sampling? Yes. So random sampling was used. Happy face. Second check. Since I did sampling, I have to check independence. How do I check it? 10% condition. Very good. That's going to give me 2 statements. So first sample, 91 English speakers is less than or equal to 0.1 all English speaking bank customers. Scooch this over a little bit. And the question is that reasonable? The answer is probably. Yes. Oh my gosh, thank you. No, we're not using the degrees of freedom. I'm just copying from the wrong place. Thank you for catching that, Caleb. No, we are using our sample size. But the table's off the board, and so I was looking at the wrong spot. Thank you. Next statement. How's it going to change? Spanish speakers, so 86. Spanish speakers should be less than 10% of all Spanish-speaking bank customers. On AP test day, a little bit less shortening in those statements. My handwriting is fat and only so much fits on the TV. The abbreviations for English and Spanish are probably fine. I'm going to assume the readers are smart. Some of that you should probably write out. Last check. We're checking that our sampling distribution, so the distribution we're using to build our confidence interval, is normal. And we have a list of 3 things we look at, and we look at them in a particular order for a reason. What is the first thing we look at? Sample size, central limit theorem, greater than or equal to 30. Good. So the question is, are our samples bigger than or equal to 30? Heck yeah. So I'm going to come down here and say 92 English speakers is greater than or equal to 30, and 86 Spanish speakers. That all came out weird. There we go. Greater than or equal to 30. So we have passed all 3 checks. We are happy statisticians. We move on to the do stage. Scoochie up. So I know my confidence interval formula, please don't judge me, is going to be sample statistic plus or minus critical value times standard error. That's the formula from the equation sheet that you're going to have on test day. And what sample statistic are we using to build our interval around? Symbols first. X bar 1 minus X bar 2. Very good. We're looking at a difference in means, but for samples. Good. Perfect. Our critical value was a T star. You guys got to get out of the habit of plugging numbers in before you plug in letters. This is the last thing I teach you in this class. I want it to stick. Last bubble. Square root. Very good. That's the standard error for 2 means. So square root, fraction plus fraction. Yes. Kaylee is on fire this morning. SX2 squared over N2. Perfect. Perfect. And nobody expects you haven't memorized. It's on the back of the equation sheet. Good. Now we plug in numbers. If this is not on your paper, you are not getting full credit for showing your work. Now we plug in numbers. Okay, so I need a copy of 7C. Oh, come on, fat little fingers, cooperate here. Okay, so 6.37 minus 5.91 plus or minus, and then our t-score was 1.988. It's nice when my brain remembers things. Times square root. I didn't really leave myself a whole lot of room here. 0. What? 60 squared 92. Six. Good. And if you are sadistic, you can plug that in your calculator as it sits on your paper, 1 for plus, 1 for minus. But we're going to use 2SAMP_T int. 2SAMP_T int should be option 0 in your statistic menu. And we have statistics, so we're going to plug in our statistics. And notice again, that spits out a wildly different degrees of freedom than we used, and that's okay. A note for those of you who, and I know there's at least one person because I saw it while I was grading, who actually evaluated this expression in the calculator. If you do that, because we're using the conservative estimate for the degrees of freedom, your interval is going to be a little bit wider than what the calculator spits out. Because the calculator is using that 100 something degrees of freedom to calculate its critical value. We used 85 as the degrees of freedom to calculate our critical value. So their T star is going to be a little bit smaller and their interval will be a little bit narrower on the calculator than yours would be. That's okay. The graders will account for both. As long as you have showed your work, you will be fine. Okay, questions so far? Questions so far? I'm seeing shaking head no. There's one more part to part A before we move on to part B. What am I missing? Sentence, very good. We need to interpret our confidence interval. So we are 95% confident that the interval from, and I'm going to round in my sentence, I don't need to be all super specific, 0.23 to 0.69 captures the true mean difference and then I have to look at what the difference was in. So what were the two means we were comparing? Mean what's? Reliability ratings, yeah. So the true mean difference in reliability ratings for English speakers and Spanish speakers at the bank. Tedious? Yes. Notice that that sentence frame came quickly. That is because I memorized it. And I'm memorizing it along with you because I don't use that in my calculus class or my college level classes. I didn't use that when I took stats in college. That's new to me. I do it quickly because I have invested the time outside of class to memorize those 4 sentence frames that we use over and over again. Put them on flashcards if you have not already. You and your friends should be quizzing each other daily. What's the conclusion for a confidence interval look like? What is the interpretation of a confidence level look like? How do we write a conclusion for a significance test? You need to have those down. That is the difference between a pass and a not pass on your FRQs. Good. Questions on part A? No. Okay, so I'm going to scroll back up so we can read part B. Yes, that was just part A. Good. Part B really is a one-sentence thing where we're going to talk about the pieces that the AP board is looking for in that sentence. So it says, does the interval in part A provide convincing evidence of a difference in population mean reliability ratings? Justify your answer. So the first thing is yes, it supports a difference, or no, it does not. So I want some thumbs. Does our interval support a difference or not support a difference? Show me your thumbs in 3, 2, 1. Yes or no? Some of us are abstaining. Those of us who are voting yes. I am inclined to agree. So I'm going to scroll back down. So, my next sentence, my answer to be, yeah, yes, this interval supports a difference in ratings and when I am making a conclusion, I am effectively performing a significance test. I need a significance level for that conclusion. So I'm going to look back at my confidence level and I want the complement. So if I have 95% complement or 95% confidence, what's the complement? 5%. So my significance level for a test would be 5% because that's the complement to the 95% confidence in the middle. Remember that confidence intervals look at the middle, significance tests looked at the tails. So if I am pairing them up, they should complement each other and add to 100. So this interval supports a difference in rating at a 5% significance level. Because, and I have to tell them how I know. Because. So remember that our confidence interval is a range of plausible values for that difference in means. And we were doing average rating for English speakers minus average rating for Spanish speakers. That entire interval is positive. Which group had the higher rating on average? The first one, which would be the English speakers. So this interval is telling me that at the 5% significance level, we can support the conclusion that there is a difference in ratings because all of the plausible values for that difference are positive. Yeah. You could also phrase it that way, in that we could draw this conclusion because zero is not contained in the interval. But our interval specifically is only positive values, meaning the plausible for the average, the population average, is that the population English speaking average is higher than the population Spanish speaking average because the difference between those means is positive, firmly. At 5% significance level, that difference is positive, meaning this bank has a systemic problem of not serving their Spanish speaking population appropriately. Frowny face. Which is some of why these statistic studies are important, right? They point out systemic bias. Good. Good. You will notice there is some information on the back. It is a check for understanding. At some point, I'll give you a little bit of time at the end of class today. Try it before Friday. I'll post the answers on Friday in Google Classroom so you can check your work. What I'd like to do now is put about 5-6 minutes on the clock to give you a break. And then we're going to move on to 7D, which hopefully will be faster because 7C is fresh in your brain. We just finished it. So I'm going to give you about 6 minutes. Get up, stretch your legs. If you need to make an e-haul pass, do it now. Next Wednesday. Yeah. Oh, I know. Give me 1 second, Carl. 1 second. Yes. And late and late. So Julian is late. Nicholas is late. Okay. Three. You're welcome. 1, 2. Oh, did you already grab some? Look at you guys. That's you grab 7D. Did everybody grab 7D? No. Okay, so that's for you and Vishal. 1, 2, 3. 1, 2. 1, 2, 3. Hello. Yeah. Oh.
I know, Carolina got that one at Target. It's different, but I like it because it's like if you squeeze it, it turns purple.
That is nice. It is very sticky though.
I know. I knew it like
I want to know what's in it. Is it air? It feels.
I don't know. I think it would be really sticky though. Like it wouldn't be like a slime or like a clay. It would be like
that feels like air.
Really?
I have a sneaking suspicion that might be air inside. Yeah.
And that's just like
it's just the material is thick and sticky. Yeah. 1, 2, 3, 4 for you guys. You're welcome. And did I get you guys 7D? No, I did not. I feel your pain, Raleigh. I did not want to get out of bed this morning. Oh, yeah, I feel like I need to wash my hands now. Could you hand me one of those? Thank you. Yeah. The squishy part is nice. The sticky part is not. That would depend on which religious group you belong to.
It's like so interesting though. Like how do two of your family members?
Is this Mormon missions?
Yeah.
Because they usually go in pairs. Okay. So Christian is a really big overarching description. Like, yeah. What's the name of your church? You don't have to share. I'm just curious. Genuinely curious. Okay.
My older brother and my middle sister, they wanted to become missionaries.
Nice. So religious belief and church attendance are different, right? You can go to church and not be religious. You can be very religious and not go to church. Sometimes they overlap, sometimes they don't. So no judgy pants in this class. Yes. Because I'm going to open the window because there's a pressure imbalance and my door won't close. So if I open the window, it'll balance the pressure, the door will close. And I cannot reach the window because I am a short king. Do not judge me. Also, it's a bonking stick, Halo. If one of you gets on my nerves, I can just go bonk. I eat dinner at 5:30. I'm in bed by 9 most nights. I am in bed at 9 with my iPad watching anime until I fall unconscious. Yes, that is the best. And I'm like, it's winter, so I'm like curled up under my big weighted blanket with my iPad and a little glass of apple juice. I'm all cozy. I just realized I left the recording on during our break, so you guys are gonna have an interesting like 6-minute gap in that video. I'm sorry. Countdown is running. We should be preparing to put our cell phones away and come back into note-taking mode. All right. Attention back up front. Eyes up front. We're going to start on the last section of 7, which is significance tests for a difference in means. We know how significance tests work. After 7C, we know how a difference in means work. We're just going to squish those two pieces of information together. So, reminders, samples must be independent, 2 separate groups. Yeah. Otherwise, it's a mean difference and not a difference in means. State plan do conclude looks pretty much the same as any other significance test, except that we're doing double all of the checks. I am defining both population means in words, because we are adults. We use our words. And we state our null and alternative hypotheses. Because the are claims about a difference, the null is that the difference is 0. Our assumption is that the two means are the same. mu1 minus mu2 is 0. And then the alternative is a statement of inequality. The mean or difference in mean, sorry, words are hard, is less than 0, greater than 0, not equal to 0. It is super important you label groups 1 and 2 clearly, and that the inequality symbol matches which one of those 2 groups is the bigger group. That is important. It is also important that everything you do is consistent with the part that you label in your state step. Because they'll ding you once if there's an error between the wording in the question and the state step, but if everything you do after state is consistent, that's 1 ding instead of multiple dings. Yeah? Okay, so next step, you check both samples for each of the 3 checks. We know that. And then we get our new formula for the test statistic. And a reminder off to the side. Our test statistic which could be a Z or a T, yeah, is the sample value minus the population value divided by the standard error. It's the formula for a Z-score, but generalized. Sample minus population over standard error for that sample statistic. So we're going to write what that looks like for Z and T. And before we do that, looking at that formula, our population parameter is mu1 minus mu2. If we are assuming they are equal, when I subtract them, what answer do I get? 0. So for these types of tests, that part of my equation is going to be 0. We are assuming that the population difference is 0. The population parameters are equal. So I end up with either Z test is X bar 1 minus X bar 2 minus 0, which we don't care about, over the standard error, which we know is an ugly fraction with a square root. And if this is a Z test, am I using sigma or SX? sigma. I have the population value, I should use it. Sigma 1 squared over n1, sigma 2 squared over n2. I'm sorry, I know that got kind of squishy. I'll make my pen thinner and see if that helps for the next one. If it is a t-test, it is the same thing, except I no longer have sigma, I replace it with Sx. Everything else looks the same. So it could be a t-test, in which case x bar 1 minus x bar 2 minus 0 over sx1 squared over n1, sx2 squared over n2. And I am sure by this point in Unit 7, you are tired of the excessive number of subscripts that we are using to label things. Welcome to college, man. If you were taking the calculus track, you would run into the same issue. The further you go in math, the more abstract it becomes, the more labeling and variables we use, the less numbers you see. It starts to feel like that. My abstract algebra class was almost exclusively proofs, where I lost points on tests for punctuation and not math. So yeah, it does start to feel like that. Also, my professor was kind of a jerk. So abstract algebra is the underpinnings of our entire math system, and how it works, like our number systems. Yeah. So we look at sets and groups and numbers and fields and how the operations work and why they work the way they do and all of that fun stuff. I thought it was really fascinating from a book perspective. My professor was not very helpful. We basically did a self-study group for that class. Okay, so all we're doing today is examples. That's it. We have the process down. Let's do some examples. I have been talking for like 30 minutes now. I'm tired. I need somebody who's willing to read example 1. Raise your hand. Thank you, Arali.
To find out, we should just pick a random sample of 33 from each side and measure the diameter at breast height or in centimeters. Here are the completed box plot in the numerical summary of the data. For instance, one should know where the data provided to give you evidence of the differences in choosing the northern side has a weight factor of the 5% a data set hypothesis for performing a significance test, considers all the parameters of input, and do check the conditions for performing the test.
Perfect. Thank you, Arali. So remember that units are decided by humans, and there was a history in human science where we weren't really great about being uniform with our measurements. For example, the Fahrenheit schedule or scale was originally based on like his wife's body temperature and then some other random natural temperature. And obviously a human's body temperature fluctuates. That was a horrible decision to base any scale on, which is why like every country but us uses Celsius now, because that's freezing of ice is 0, melting of ice is 100. Nice even degrees between them. I don't know if you can tell, but as somebody with like graduate degrees in physics, I hate British imperial units with a passion. I hate that we use miles and pounds and Fahrenheit and why. So that measurement, diameter at breast height, is another artifact of some idiot who was in charge of standardizing things used their height as a basis for measurement, and now we're stuck with it. All right, back on track. First question after we do our first read is, what the heck is it asking us to do? And the answer is not build a confidence interval or test. Yeah, not perform a significance test. So state hypotheses, check conditions, define parameters. Perfect. About half the questions in your homework are only going to ask you to do those things. Most of the questions on your homework are not full problems. Please read the directions and answer the question that is being asked. Otherwise, you're going to do like 10 times more work than you need to. Yeah? All right, so we're going to go ahead and do that for this problem. I'm going to start with A. So I know that this is a significance test for two means. For two reasons. One, I was given two clear groups, trees in the south, trees in the north. And in the table, they gave me means, not proportions. So the very first thing I should do is define my means. You have to make decisions. I am going to follow the directions that they were given in the problem in the table. North is the top row, south is the bottom row. So mu1 is for the north, mu2 is for the south, and we were calculating the mean what? Yeah, that DBH. Good. So this is the population mean DBH for trees in north. And I could be a lot more specific. I could write out diameter at breast height. I could write out trees in the north of this preserve tract. This is a timed test. Just enough information to tell them you know what you're talking about. Mean 2 should be the same, but for trees in the south. So quotation, 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 south. Yes. Time-saving measures. Remember that this clearly indicates copying, whereas abbreviations, if they're not generalized, are harder to interpret. Good. There was one other thing they asked me to do, which was hypotheses. So I'm going to set up my labels. Null hypothesis label, alternative hypothesis label. I know I'm looking at a difference in means, so my variables should be mu1 minus mu2. I know that the default for the null is equal to 0. We assume that the population means are equal. And then we scan the word problem for a hint about the alternative. And I see a keyword in the sentence beneath the table. A difference. Is there convincing evidence of a difference? So what symbol goes in my alter? Not equal to. Very good. Not equal to 0, because difference could mean that either mean is bigger. I just want to know if there is a difference in the means. I don't care which one is different, just which one. Is there a difference? Good. Mostly done. Next thing said, check that the conditions are met. So, Halo, first condition, random. So we ask ourselves, random sampling or random assignment? Good. We had 2 random samples of 30 trees each. Right, independent samples of 30 from the south and the north. Good. Julian, second check. It is independent. Very good. because we did samples, I need to check the independence condition. And I heard 10% whispered, and I agree. So 30 trees in the north is less than or equal to 10% of all trees in the north. And 30 trees, I'm getting tired of writing, in the south is less than 10% of all trees in the south. Hey, you wanted to do this once today. I have to do this again in 6th period. It chose me. You laugh. All of my family are either teachers or nurses. I only had 2 choices, and I don't deal well with blood. Last check. Lisbeth. Normal. Before I write normal, would somebody correct my horrible spelling, please? There's like a whole syllable missing in that word, guys. Come on. But snaps to Lisbeth, you are correct. The last checked is normal. And the question is, how do we check for normal? So Julia, how do we check that we're normal? Very good. We start with sample size and the central limit theorem. Perfect. So 30 trees in north and 30 trees in south. Those are my samples. And in both cases, they are greater than or equal to 30. Just barely. We squeak in at that 30 cutoff. Yay! Happy face. That's all the problem asks us to do. I see some happy looks. Good. Very good. Let's try another one. Maybe if I can get my TV to work. There we go. So we're answering the questions that are asked. We're not doing extra work today. Example 2 says, refer to the preceding example. The table summarizes data on DBH in centimeters of independent random samples of 30 trees from each north and south of the Wade Tract Preserve in Georgia. Calculate the standardized test statistic. Find the p-value. What conclusion would you make? Essentially, this is baby stepping our way through the question. They asked us to do the state. They asked us to do the plan. A and B are the do. C is the conclude. So some of your FRQs will be structured like this, where they're going to baby step you through it. So for A, we are calculating a standardized test statistic. And I need to ask myself, Z or T? T, very good, because we only have a sample standard deviation. So my standardized test statistic T is going to be x bar 1 minus x bar 2 minus 0 all over square root of sx1 squared over n1 plus sx2 squared over n2. Write it out in symbols. Nod your head. Yes. And then we pull the numbers from the problem. We shove them into the equation. We run 2SAMP T test, and the calculator will calculate it for us. So for numbers, pulling values from the question, we have 23.70 minus 34.53 minus 0. And then in the denominator, we know the bottom of those fractions are both 30. Sample size was 30 for both. Standard deviation for group 1. Jeanette, could you give me the standard deviation for the north? 17.5 squared. And then south is 14.26. Yeah, okay. You can only see the bottom row of the table. Good. You could, if you wanted, plug that in your calculator. We're going to run 2SAMP T test. 2SAMP T test, which is option 4, yes? We have stats. We are going to enter the stats. So 23.7, 17.5, 30, 34.53, 14.26, 30, and then our mu1 should be not equal to mu2. We don't want it pooled. We go down to calculate, and I am getting negative 2.628 rounded. 2.628. Negative makes sense because in the numerator I can see first number minus second, first number smaller. And then I'm going to calculate a test or a p-value. And I don't have to really do anything here, but I am going to draw my picture. Because this is what counts for showing work when I'm doing a significance test. I don't have to show how I found the p-value, but I need to draw the picture to interpret it. So I'm going to mark my test statistics. It's a little past negative 2.5. It's sitting right here. This was a different than test. What does that do to my picture? Good. Flip it to the other side. So I should have another tail over here at positive 2.628. And I'm going to shade both tails. And I know that those two tails together are going to form my p-val. And then I'm just going to copy what my p-value is from the problem. Maybe. And my calculator is spitting out 0.011. Perfect. Out of curiosity, on page 1 of 7D, what significance level were they asking us to use originally? 5%. So my alpha, so that's less than my alpha of 5%, 0.05. If my p-value is low, what do I do? Reject HO. So for my conclusion, C, because the p-val of 0.011 is less than alpha equals 0.05, we reject HO. That is the first sentence. And I am hoping we have seen that sentence frame enough that you have it in your head, whether you want it there or not. There is a second sentence. I heard Caleb mumble yes. And the question is, do we have evidence or do we not have evidence for the alternative? And we do. It is yes, yes, or no, no. So if it's yes, we reject. Yes, we have evidence. If it's we fail to reject, we fail to have evidence. So yes, yes, or no, no. So yes, we're rejecting. Yes, I have evidence of the other guy. So we do have convincing evidence that, and as you can see, I am running out of space. What comes after that dot, dot, dot? Context from the problem. Very good. I'm going to describe that difference of means in words. So we do have convincing evidence that there is a difference in the mean diameter at breast height for trees in the northern part and southern part of this tract of land in Georgia. And remember, when we did our FRAPPY in Unit 6 and we took a look at that scoring guide, missing one of those two sentences was big point deduction. Because they had a list of things they were looking at. If you were missing any one thing from that list, automatically from an E to a P. Okay. Questions so far? What time is it? Oh, we're good on time. Look at us. What was the what, huh? That was our p-value from our calculator. It was a p-value from our calculator. It was right beneath our test statistic when we ran 2-sample t-test. Yeah? You think I did that correctly? Nobody said I did it wrong. I'm missing it. Okay, let's try another one. Scoot you up here. So 3 says, does increasing the amount of calcium in an adult's diet reduce blood pressure? Researchers designed a randomized comparative experiment to find out. The subjects were 21 healthy adults who volunteered to take part in the experiment. They were randomly assigned to 2 groups. 10% of the subjects received a calcium supplement. Control group of 11 subjects received a placebo pill that looked identical to the calcium supplement. The experiment was double blind. The response variable is the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here are the data. Do these data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo on average for healthy adults like the ones in this study? Interpret the p-value that you got in part A. So we're not going to do the full state plan do conclude, but we are going to do the big important parts, which is I got to state my hypotheses. We're verbally going to go through the check. We're going to do the math together. We're going to interpret together. Yeah? So the first question is, why is this a difference in means and not a mean difference? I just heard different sample size, which is true. We had 10 in one group, 11 in another. So they were not paired up, identical individuals getting one getting one getting the other. So there's issues with my samples aren't paired, which would be the first clue. If I've got different sample sizes, I'm probably not doing a matched pairs experiment. And matched pairs is how we get paired data. The other clue is I'm already looking at differences in before and after for each person in the study. And then difference of differences gets a little weird. A mean difference of a difference gets complicated. But for you, I think Mario hit the nail on the head. That difference in sample size is a big clue. The other clue is they are pretty explicit on the AP test when it's a mean difference. And they will indicate that you need to subtract one versus the other. And they did not do that here. So, I see the keywords that are telling me this is a significance test. What keywords are telling me significance test? Yes, very good. Provide convincing evidence. I know that's asking me test a claim. I should identify what the claim is, what the parameters are. And in this case, it says that calcium supplements reduce blood pressure more than a placebo. So the first thing I'm going to do is I'm going to define that mean difference. So the decrease in systolic, which is what we're talking about, for calcium is going to be mu1. The decrease in systolic for placebo, that's going to be group 2. Because I like to do things in the order they're given to me in the problem. That's helpful because that's going to determine the inequality that shows up in our alternative. I know it's a significance test. I know it's for 2 means. I know the basic setup. Mu1 minus mu2 equals 0. Mu1 minus mu2 is unequal to 0 somehow. I just need to fill in that blank in the middle of my alternative. And they specifically say in part A, evidence that calcium supplements reduce blood pressure more than a placebo on average. And this is where we're going to have to really think about what those numbers are, because they tell me above the table that increases in blood pressure appear as negatives. Decreases in blood pressure are then positive numbers. So if increases are negative, decreases are positive, yeah? And they are asking, do calcium supplements reduce blood pressure more? And if reducing, decreasing is positive, the more I decrease, the more positive my number will be, yes? So if calcium is better than placebo, I should have a bigger positive number for calcium than I do for placebo, yes? So decreases in blood pressure are represented by positive numbers. If calcium is better at decreasing, it should have a bigger positive. And calcium is group 1, so calcium is a bigger positive number than whatever's going on with a placebo. If 1 is a bigger positive than 2, what inequality goes here? Greater than. Positive. I want that difference to be positive because I want group 1 to have a bigger number than group 2. More to the right on the number line. Good. Okay. Significance level. Were we given one? I don't think so. So we're going to choose one. And 0.05 is usually the default. If this were the AP test, I would write that sig level, comma, alpha equals. We go through the checks. First is random. And in this case, I see an important key phrase in that paragraph above the table. Random assignment. Yeah. We had 10 subjects, 11 control, and they were randomly assigned from 21 healthy adults. Random assignment means I'm going to skip the independent and go straight to the normal. So sample size, are we bigger than or equal to 30? No. In the problem, are we told the population is normal? No. How do I check for normality? We graph those data. We would build what type of graph? Dot plot. We're not going to do that now. You know how to draw dot plots. You should, for that check, make dot plots for both and compare them, just like we did yesterday. Yeah? You guys know what dot plots look like. We're going to assume, for the purposes of time, that those dot plots have no strong skew and no noticeable outliers. The next step is the do. What am I calculating in the do step? Brody, what am I calculating in the do step? There's two things I need for a significance test. What two things did we calculate in the last problem? The test statistic and the p-val. Good, test statistic and p-val. And so I have to ask myself, Z or T? And I think this is a T because I was only given sample data. So this is a T test statistic. We write the formula with symbols first. Yeah, I know. I feel your pain, dude. The more you do it, the faster it goes. That's why we practice. I want to plug in numbers, but I don't have any yet. So the question is, how am I going to get the numbers to justify my work? List. Shove calcium in list 1 and placebo in list 2, because those are the assignment numbers that I gave them at the beginning of the problem. And then run 2 sample t-test. Very good. Reminders, if you're clearing out a list, go to the list name and then press clear enter. Ooh, oops. Give you just a minute to catch up. Please check my work. I am known to make typos, particularly when I'm in a hurry. I see some nodding. That's a good sign. Sorry, I'll get out of the way. Don't judge me. I cannot help that I am allergic to everything on planet Earth. Okay, so I should draw something here, which is my picture. Yeah, I know, everybody's favorite part. Horribly drawn picture. Those tails should be smaller, but you get the general idea. What should I write here? Sentences, yeah. I'm not going to do it because you know what those conclusions look like. But conclusion here. Because the p-value is greater or less than alpha. Greater than alpha. Because our p-value is greater than alpha, we fail to reject the null. We do not have convincing evidence. Good. This is a fail to reject because this is bigger than alpha. Do not have evidence. Yeah. Good. And you have those sentence frames. I'm less concerned about that than I am about B, which sometimes pops up in the multiple choice, sometimes pops up in the FRQ, which is, do we know how to interpret in words what that p-value we just calculated represents? And I heard mumbling when I asked the question, and a lot of you were on the nose in terms of the concept in your brain, which is perfect. The general idea is if I were to collect samples, like the samples I collected here, same size in the same way, and I repeated this study over and over and over and over and over again the same way I did here, I expect about that % of the resulting samples to produce a test statistic as extreme or more extreme than the one that I saw. Because that picture that we drew in part A represents the sampling distribution for all possible samples like the one that we collected. And we're marking off the most extreme 6.4% of them. That's what we have marked off with that test statistic. This is another sentence frame, sentence structure that is worthy of note cards. It is less frequent than the 2 for significance test, the conclusion sentences. It is less frequent than the confidence interval and confidence level questions, but it does show up. And it is important that you have the concept of what a p-level is measuring down. The wording is less picky, but you need to understand what a p-value is telling you in terms of that's a percentage of possible samples that are as extreme or more extreme than mine. So we're dividing up all possible samples into likely and unlikely. Yeah? Good. There is one more question that I'd like to go over with our time, and it's not going to involve any math. We're done with math for today. The next page, there are a couple of settings, and what I want you guys to discuss is whether those settings represent a difference in means or a paired mean difference. Meaning, can I use a 1-sample t-test or do I have to use a 2-sample t-test? So I'm going to put about, what time is it? 8 minutes on the clock. I want you to discuss, and then we'll go over. What we don't finish, we'll wrap up beginning of class on Friday. Yeah? All right, we know what that beat means. It's time to come back together. We're going to go through these real quick. So A says mechanic in charge of a large fleet of electric golf carts at a golf resort has 2 brands. To see if one brand has better batteries, mechanic randomly selects 10 golf carts of one brand, 10 golf carts of the other brand, records number of hours of each cart before the batteries must be recharged. So raise your hand if you have a suggestion on what this is. Kaylee. So Kaylee's vote is for 2 sample. Can I get a thumbs up if you agree with Kaylee? I see thumbs up popping up around the room. Very good. Can somebody else explain why it's 2 sample? Jeanette. Very good. The point of this is a comparison between 2 independent brands. Good. Very good. So 2 independent brands, 2 independent samples of 10. Happy face. Snaps. All right. Number 2. Part B. The mechanic in charge of this fleet of gas-powered golf carts wants to know if fuel additive can improve fuel efficiency. 20 carts currently waiting to be filled. All 20 are filled with the same gas. Mechanic randomly selects 10 of those 20 and puts in fuel additive. So we have 10 carts with fuel, 10 carts with fuel plus additive. The carts are driven until the fuel is used up, and then the fuel efficiency of each cart is measured. Volunteer. Jeanette?
We think it's paired.
So Jeanette thinks it's paired. Can I get a thumbs up if you agree with Jeanette? And this is less confident here. How many of you, instead of paired, thought 2 sample? I see you 1 or 2 thumbs up. This is one that your explanation will determine your grade, because you could go either way with this. So as long as you explain your thought process, you would be fine. My instinct, since I am comparing pure fuel and fuel additive, and then I am measuring the fuel efficiency of each cart, and they didn't at any point mention that I'm interested in a difference between the way they worded this, my instinct would be to run it as a 2 sample. But because this is so ambiguous, you could run this one as either. I swear I know how to write. Come on, Ben. 2 sample. So my instinct is this, but that's because I've been doing this a long time. You could argue either. This one is ambiguous, and that's okay. Some of these, the emphasis is your explanation and less your answer. Can you justify why you chose what you chose? That one could go either way. The last one, mechanic in charge of a large fleet of electric golf carts has 2 types of new tires. Mechanic labels 5 slips of paper type A, 5 more slip with B. Mixing the slips in a container, selects 10 carts from the fleet, pulls out 1 slip for each cart. Mechanic installs the type of tire written on the slip of paper on the front driver's side. The tire of the opposite brand is installed on the front passenger side. After 6 months of use, the amount of wear on each type of tire is compared for each cart. And this one screams an answer to me. Who wants to volunteer theirs? Raleigh, what did you say for this one? Raleigh said paired. Can I get a thumbs up if you agree with paired? And I see at least 2 more thumbs up. Does that mean everybody else said 2 sample? I'm going to write a Raleigh's answer down and then explain why. because my instinct is paired. Big, heavy duty for this one, paired. Everything about the wording in that question screams paired to me, and the question is why. So we have two tires, yes? Tire A, tire B. Both tires are going to end up on every cart. I have 10 identical carts. Each cart is going to get a tire A and a tire B. This is similar to a human doing placebo and then treatment, or treatment and then placebo. Both treatments are ending up on the same vehicle. That screams to me paired. What I'm randomizing is which tire ends up on driver's side and which tire ends up on passenger side. Some will have A and B, some will have B and A. All of them will have both. And since I am collecting data on both tire A and tire B from every subject, those data values are paired, because I'm going to have an A value and a B value from each car, each golf cart. That, by the way, is why I said, because I've been doing SATs a long time, that option B is likely a 2 sample. Yes, I had 2 treatments. I had a fuel and then a fuel plus additive, but the data from fuel and the data from fuel plus additive were coming from 2 different carts. So yes, I could, if I assume the carts are identical, run it as paired, but those 2 data points are coming from the same cart. I have to run it as paired. This one, there's flexibility, depending on whether the carts are identical. This, it's the same cart. Has to be paired. Anytime you've got 2 data values coming from the same sample, the same person, the same cart, the same object, run it as paired. Good. Good. We are done with Unit 7. Yeah. Friday, we're going to do a Frappy, and then you're going to have work time. You can spend it on your homework or your study guide. Homework is due on Monday. Monday and Tuesday in class, we're going to review. Yeah? Staff meeting today, but I'll be available after school Thursday and Friday. I'm going to start AP testing review on Saturdays. I'm going to alternate. This week, it'll be in the evening. Next Saturday, it'll be in the morning. So I'm going to alternate and try and catch everybody, because it was about 50% wanted morning, 50% wanted evening. So we'll alternate. Yeah? You can't make every Sunday. You can make Saturday. You can make some of them, and I will record for those of you who can't make it. Was that your question? No. I'm going to post that in Google Classroom probably tonight when I post the schedule. That's a good question. I'll do that every week. Jaden asked a good question. What are we covering? Every week, usually Wednesday or Thursday, I will post the meeting time for Saturday along with what we'll do that Saturday. This Saturday, I'm planning on some calculator drills, some vocab and symbol Kahoot, maybe some error analysis if we have time. Whew. Good job. I know that was rough. Thank you for your attention.